A very good evening, guys. Today we are back with another problem, and today's problem is palindrome linked list. So let us understand the problem first. We'll be given a single linked list of integers. We have to check whether the linked list is palindromic in nature or not. So let us first understand what is a palindrome. So say for example, if I take the word race car, so if you see, this is a palindromic word because if I read the word from the reverse to the front and from front to back, it just means the same, and the order of the sequences are also resembling the same sequence. Now let us understand in the terms of a linked list. So if I have a 1 2, then 2 1, so this is not a palindromic linked list, so it is going to return false. Now let us take another test case. So now we have another test case which is saying 1 2 2 1. So if I read it from backwards 1 2 2 1, the output which I will get is nothing but a true. That means it is following a palindromic sequence. Okay. Now what is the approach? So the initial approach will be, what we can definitely do is we can convert this thing into an array. Okay. So if I convert this thing into an array, so the array will look like this 1 and 2, and now if I try to reverse this particular array, I can reverse it and I can return it. Similarly for this, what I can do is I can create an array of 4 integers. Okay, the integer value will be 1 2 2 and 1, and I can reverse the array and check whether it matches the initial sequence or not. If it matches, I will return it as a palindrome. But the problem here with it is that it is going to require an extra space for this particular array, and the reason we are taking an extra space, this is not a very good and optimized approach. So the first approach which I told is that we have to convert the linked list into an array. We have to check the reversed array is same as before, and we have to return true if it matches. So the time complexity we are using over here is big O of n because of the extra space due to that particular array. Now what can be the better approach or the most optimized approach? The most optimized approach is using a 2-pointer approach. Okay, so now let us understand and analyze the 2-pointer approach. The 2-pointer approach is basically saying that we will have 2 pointers, okay, a slow pointer and a fast pointer. So I will write this is a slow pointer and we will have a fast pointer. So we have 2 pointers, slow and fast pointer. So slow pointer will iterate through the entire linked list one at a time. That means from here it is going here, okay, and from here it is again going here, from here it is going here. But now I also take a fast pointer which skips the element. So by the time, say for example, I am at this position, it will skip one element and it will reach over here, and immediately it will go to the end of the linked list. So we can say that when my fast reaches the end, my slow is in the middle. So what I can clearly say that fast pointer is skipping elements, whereas slow pointers is taking one at a time. Okay, now here there is no involvement of an array, so we can say that the time complexity which we will be using is big O of 1. Okay, now here is the algorithm. First we have to find the middle of the linked list, okay, and then we have to reverse the second half of the linked list. So in this case, the middle of the linked list we are getting till here. We have to reverse this particular value, so it will become 1 and 2, and here in the first half we have 1 and 2. So the first half matches the second half after reversing, so we can say yes, this is a palindromic linked list. Okay, now let us take the example of the algorithm. Initialize. So we will be having a slow pointer. Slow pointer will point the head, fast pointer will also point the head of the linked list. Okay, so if a linked list, if you don't know guys, so we have a node over here. Okay, we have a node over here. This value is known as data. Okay, we have a next value and we have a previous value signifying the previous and the next pointers. So initially it is going to point the head value. Slow and fast are going to point the head. Now how we are going to find the middle? So we will be iterating a loop. The loop will first check whether my fast is not null, means fast contains some value, and whether my fast.next is also not null. What is fast.next? Fast.next means already something is ahead in the race. Okay, we are checking the value which is again next to the present element. So if it contains some value, only then we can iterate through the loop. Okay, the loop will iterate till this value becomes null. So if it gets null, then it is not going to iterate and it is going to stop. So first we are going to check, as I told, we are going to move the slow as slow.next. Okay, and then we are going to move the fast pointer 2 steps. That's why I am writing next 2 times over here. Fast equals to fast.next.next. Okay, now we have got the middle of the linked list. Now how we can reverse the second half? Now you will say enough, that what is the middle of the linked list. Slow is pointing the middle of the linked list. As fast has already reached the end of the linked list. Now slow is pointing the middle of the linked list. Okay. Now let us come to the second half. So reversing the second half, how we can reverse? We are going to initialize this particular previous value as null. Okay, we are going to set it as null. Means previously it does not hold any other linked list, has any other elements in the previous counter. Okay. Now we will be iterating a loop where the slow pointer is not null. So we can say our next node is nothing but our slow dot next. And for reversing, we can see this particular next node is equals to previous. So we can tag this slow dot next to the previous value. Okay. Now what we will be doing is we will be moving previous to slow and slow to the next node. Okay. Lastly, what we will be doing is we are going to compare. So how we can compare? We will take a left and right value. Left is and right value. Left will be showing the head position and right will be storing the previous position initially. Okay. Now we will be iterating the loop where the loop goes like this, that till my right value means the previous value which is stored initially is not null. So what I will be checking whether my left data is equals to right data, just like the concept of any palindrome's nature. If it matches, then what I will be doing is I will be moving the left pointer ahead and the right pointer also ahead. If this condition does not matches, I am going to return a false. I'm going to return a false. So this is a most optimized approach with the help of a two-pointer approach. Now what we will be understanding is we are going to understand the code. So we will be doing a code analysis of this code. So this is a Python code. As we can see, we have created a class, then we have defined a function is palindrome. We are taking the head of the linked list over here. First we are checking the base cases. We are checking the base cases. The base cases are checked like this, that if the head is null, okay, and the head dot next is also null, then we are going to return true, or else we are going to return false. We are initializing slow and fast pointers as head. We are checking that fast and the fast dot next. Our loop is going to run from fast and the fast dot next. Okay. So we will be moving the slow pointer one step at a time. I can write one step at a time. Okay. And similarly, we will be having a fast pointer which will move two steps, means skips steps, or we can write skips steps. Okay. Now we are initializing previous as null, and in the while loop what we can see that now our task is nothing but to reverse the second half. What I can say is reverse the second half. Reverse the second half. So in the reversing of the second half of the linked list, my next node will point the slow dot next, and the slow dot next will become previous and the previous will become slow. And similarly, with the help of swapping functions, we can swap this particular thing. Slow becomes the next node. Lastly, what we are doing is we have a left and right pointers. Left pointer being head and right pointer is storing the previous value. We have to run a loop and check whether the left is not equals to right. So in that case means the palindrome condition is not satisfied. The first two values of the linked list does not matches with the last two values. That means it is going to return a false value. So what we are going to do, we are going to move the left pointer ahead and the right pointer also ahead. If it is true, then we are going to move the left and right pointers ahead. Okay. So that's how we have done the code analysis of this particular problem statement. If you guys could understand this problem statement, please drop a comment down and tell me your reviews of this particular solution. I'm going to submit this particular solution and check whether it works or not. So as you can see, we have solved this particular problem statement. Make sure you guys like, share and subscribe to the channel. Thank you so much, and I'm looking forward to see you in our next video.